Okay, welcome back everybody. This is going to be what I've loosely termed the advanced syntax module. And basically what this module is a kind of catch-all for a whole bunch of concepts that we want to make sure that you have a kind of foundational knowledge in prior to going into things like WPF or web service development. So what I've done is I've taken a different approach than using PowerPoint slides, because I feel like PowerPoint slides are a little bit bloated and you don't necessarily get all of the kind of high level information or the takeaways very easily. So instead, what I've done is I've put up a Canvas page that steps you through the kind of big five different things we're going to cover in the module. So in this first video, what we're going to do is we're going to talk about all the different ways that the question mark symbol is used in C#. And this feels a little bit silly to really talk about because this question mark symbol is used for a variety of different things. And there are three primary ones. And while two of them are related, one of them is certainly not related necessarily. But what we want to do is make sure that if you're going out to an open source system and you're trying to read production code, it's very, very likely that you're going to see these question mark symbols all over the freaking place. And while we've talked about null propagation and the ternary operator before, we have not talked about null defaulting or coalescence before. And when you start seeing all of these things at the same time, sometimes it gets confusing which thing is being used where, and it really becomes a familiarity issue more than anything. So what we're going to do is we're going to talk about them kind of side by side and look at some common use cases for them, so that hopefully you'll be able to use them to make your code cleaner and easier to read, and B, you'll be able to actually read some production code and understand what has happened in the past. And so at a really kind of high level, what null propagation does, again, is helps us get around this situation where we have just a crazy number of null reference exceptions in production code at runtime because of the situation where there are a tremendous number of reference types in C#, and each of those reference types is defaulted to a null pointer when it is created. And so what can happen is if you try to access a method, or you try to access a field or a property on a null reference or a null pointer, you will get this exception and bad stuff kind of happens. Everything after that will fall by the wayside. You will have code that doesn't actually run. So your application, be it a client server application or a console app or whatever, will be in this sort of indeterminate state, which is not necessarily what you want to see. So what null propagation does is it says, instead of throwing an exception, what we're going to do is we're going to literally propagate the null down the call stack. So if I try to access a method on a null pointer, what I'm going to get back is a null value rather than a null exception that gets thrown. So what this does is it keeps code safe. It doesn't require additional exception handling in order to not blow up the code because of a null reference exception, and it also compresses the code. So if you don't have a very kind of specific thing that you want to do with a null reference exception in terms of error handling, this is an easy way to either swallow that exception in a meaningful way, or at least handle it so that you don't enter an indeterminate state. You can always just kind of handle the one null at the end of the call stack. Null defaulting is a very similar situation, and I talk about what syntactical sugar is in here. But basically the idea is that these modern languages, what a lot of the times happens is as they mature, they will obviously have features added to them, and some of those features are not necessarily necessary. They don't provide a functionality that was not previously there, and usually that is referred to as syntactical sugar or language sugar or compiler sugar. It's basically just an accoutrement. It's an additional thing. So null defaulting or coalescence is exactly that. What it does is it uses this double question mark operator And it says anything to the left of that, if it is a null, then instead of providing the null value back to the left-hand side, what we're going to do is we're going to provide whatever is on the right-hand side of that coalescence operator. And so effectively what this does is it allows you to specify a default value without having to go through a conditional. So you don't have 5 or 10 or 15 lines of conditional code, if, else, all that. To simply set a value for a null. So you often see these two things paired together. You will propagate the null all the way from the very first call to the dot syntax all the way to the end. And then at the end, you will see a coalescence operator that gives you a default value that is then passed to the left-hand side, or it is passed to a conditional or something for handling. So again, null propagation can be used as a sort of de facto error handling technique. It's often used in conjunction with null defaulting because you can actually set a default value for what happens if you get a null value. And then the last place it's used is as a ternary operator. And so these high-level languages or 4gen languages very often have a ternary operator. It's exactly the same thing that you would expect from any other modern language. You have some condition, and then you have a question mark, and then you have what happens if it's true and what happens if it's false, and that's it. So we talked previously about this syntax, and we did some examples of how you can compress an if-else statement into a ternary operator. But I want to kind of bring this back up because what will happen is potentially you will see null propagation and null defaulting inside of a ternary operator. And then that one line of code could have 15 question marks. And things get really, really kind of confusing if you're not familiar with all three of these things being used in tandem. So that's at a high level what we're going to do in this code along. It's going to be short and sweet, but I want to make sure that everybody's kind of comfortable with what it means. So first of all, what we're going to do is we're going to go back and we're going to talk a little bit about partial classes again. So for the purposes of talking about null references, it's really easy to make a whole bunch of null references if I just make my own reference type. And so if I do something like partial class data, and I give this thing just some public properties. So public int my int, the getter and setter. And I have public string my string, I get a set. What we'll see is I can have a public static void main, a string ours method, and I can set up a new data, so just call it data equals new data. And what I can do is I can say console.write line, write the contents of my int. So data.my int equals data.my int. And so again, this is just string interpolation. It's a sort of fancy new feature, I believe as of 4.6, so it's not all that new, but it makes string concatenation really easy. It's something akin to like a Python format statement, something like that. If I add my console.read line to the end here, what we would expect is I get this build error here, and I say, no, I don't want to see that. Static main method. Oh. capitalization. Okay, so this is going to give me. So this is the default value. So this right here is a non-nullable thing. So I get the non-nullable default value here. If I have something like partial class data member, and I have another public int my int with a get and a set, and a public string my string with a get and a set. And now I put this nullable reference type, so I can have a data member called my data member with a get and a set. And suddenly, instead of this non-nullable type, I want my data member dot my int. I should be able to do something like data member, and that should work. But I get this null reference exception. So this is the thing that we're going to try to get rid of with null propagation. So what is happening? I have two reference types. The first reference type I am calling the constructor on, and because I'm calling the constructor, that default constructor will take all of the default values for each of these properties, and it will shove the default value into each of these properties. So this one and this one is totally fine. These are well-known non-nullable types. So this thing is going to be a 0. This thing is going to be an empty string. However, when we get down here, this is also a reference type that I have created. And so actually, if you remember the naming convention, why these things are yelling at me is because these should be capital, because these are public. So I'll just make them consistent. Capital and capital. So I've called the default constructor on this top thing, and that has gone through and has given me the default value of each of these properties. The default value of a reference type, which data member is a null reference or null pointer. So here, because I have never called the default constructor on data member, I get a null pointer here, and now suddenly I have a null pointer with a reference to my int on it, and that's what throws the exception. So null propagation. If I put a question mark right there, what will happen? So if I run this thing, I will get nothing. And the reason is because now, instead of throwing the exception, what I'm actually getting is this thing is a null pointer. This would be an exception, but null propagation passes the null forward in the call stack, or the reference stack. So what this is going to give me is a null. The string representation of a null is just nothing. And so this is a much happier situation than we otherwise would have, right? We don't have a crash. And so if I had code between this write line and this read, it would run correctly, and everybody would kind of see what they would expect, to see. So again, when I did not have this, and I only had this, I do not have a null reference exception. The reason is because I've called the default constructor. The default constructor gives me the default value of each of these non-nullable properties. The problem is when I start adding reference types, and this reference type has a default of a null pointer, and so then I start accessing stuff on a null pointer, bad things happen. So what happens? So this kind of covers this stuff. So that is what null propagation does. This sentence is really hard to kind of follow, but hopefully the example kind of makes sense. Anytime you could have a null reference exception get thrown, you can turn that thing into just a null value by using null propagation. That's it. So null coalescence. Let's say that I didn't want this to print some kind of weird thing. What does it mean for my int to be nothing? We think that this thing is an integer, so we would actually expect this thing to be a 0, because we saw down here the behavior that the sort of CLR gives you out of the box is for a non-nullable int to return 0. So how can we make that happen? Well, we could go through this whole exercise where we say if data.myDataMember is null, then set data.myDataMember to a new data member, and then set this whole cascade of things that defaults this value and then defaults this value by nature of the default constructor to 0. That is certainly one way to do it. An additional way of doing it would be actually in the default constructor of data to call the default constructor of data member. And so I'll do that as a final step. But if I didn't want to do any of that stuff, what I could do is something like this. So what I have said now is, because I've used this, if the left-hand side of the operator returns to me a null, what I actually want to return is a 0. So if I run this, what I get now is something that makes a lot more sense. I've got data.myDataMember.myInt is actually 0. This 0 comes from this value. So what this coalescence is doing is it's giving you a default that gets returned if and only if the left-hand side is null. So you don't have to use null propagation in order to get that null. But it kind of makes sense to use these two things in tandem or together. They kind of complement each other quite well. So that is kind of that. This gives us the ability to do defaulting without a whole bunch of work around like conditional statements and all that kind of stuff. So what you'll find is this kind of syntax will be all over the place, particularly where people are wrapping APIs that were legacy. They're trying to wrap logic that exists in code that may not be upkept anymore, or code that has a whole bunch of known issues, and people are kind of standoffish about actually using the API. What we will talk about when we get closer to the architecture components of the course is that it often makes a lot of sense to actually provide something like public data and changing the default constructor of data to say that my data member equals a new data member. And what this is doing is this is saying it doesn't matter if somebody tries to access my data member without actually setting it themselves in their code. They don't have to have an if statement up here that says if I'm returned a data item that doesn't have a my data member, set my data member to something default. The class itself that's being called has implemented that defaulting behavior itself. This is much better encapsulation than this. It's much better coherence. You don't have a situation where the person who is in this class has to understand or care about a whole bunch of stuff in the data class. This is more for safety. It is not necessarily good programming practice. If you have access to both the class that's being called and the caller, ideally you would do something like this, because this will fix all of the callers, while this is just a clever way of fixing this one caller. So this is kind of a localized safety technique. This is a much more global fix. Reasons why you might not want to do this, or if data member is this just absolutely monolithic, crazy big thing, you wouldn't necessarily want to set it up all the time. And in that case, you would want to maybe use not even constructors. You would maybe actually want to use a factory method or something like that to return this class. And we'll actually go through that in the architecture discussion. So to wrap all of that up, we could also see something like if so var value equals this. And then another question mark. And then that could be string dot empty, or I'm not empty, something like this. So this is a extremely cooked up situation where if I have a call out to my data member that gets past a null reference, or for whatever reason results in 0. So if I have this situation, which will also result in 0, what I'm going to do is I'm going to pass back an empty string. If not, I'm going to pass I'm not empty. And so what we can do, say console.writeLine value, just to kind of show what that's doing. And so here, this is true, 0 right here. And so what I've returned is string.empty. So we can make this a little bit more explicit by saying I'm empty and running that up. And so now we will see I'm empty. So kind of the point of putting all of this stuff together is that if you have access to an open source system or something like that, you're trying to dig through code and you see tons and tons and tons of question marks, each of those question marks could be doing drastically different things. And so this one line of code has examples of using the question mark for 3 different things. The first one is null propagation, which is keeping you from exploding on a data access. And instead, it passes a null to the next access. Then we have coalescence. It's telling us if this thing is null, then actually return a 0, because this thing is an int and it doesn't really make sense to have a null int in some cases. Then over here, this is actually a ternary operator that's saying if this thing is true, then return this value. If this thing is false, return this value. And so like we saw with the previous lecture, you can nest ternary inside of ternary inside of ternary. You could have null propagation on every data access point. You could have tons of different coalescence operators that are happening for every returned value. These things can just sort of balloon into tons and tons and tons of different use cases that are all strung together. And what I want to be very clear about is these are doing fundamentally different things in slightly related ways. And it's very easy to lose your way when you're trying to read somebody else's code. So to wrap it all up, the point of this stuff is to make your code more readable. If you are new to C# and you're reading legacy code that has a bunch of safety stuff in it because people have been burned by an API, you can very easily lose your way because you're not used to seeing all of these similar symbols used in drastically different ways. So I wanted to kind of show them all at the same time to kind of get everybody on the same page. So I hope that's useful. If you have any questions, comments, concerns, please let me know, and I'm happy to further clarify, and hopefully this stuff will start helping you on the second programming assignment. Thanks a lot, and talk to you later.